Welcome back to Brilliant by Numbers with Naina McFarlane. This lesson will be all about non-right angled triangles, so stay tuned. Hello my BBN family. Before I begin, let me apologize for the absence of your regular weekly uploads. If you know the passion I have for teaching math, you would know that my absence was in no way intentional at all. However, I just really had a lot going on, guys. But I'm so happy to be back with you, and I'm actively working to get back on track and will resume your regular content. Thank you so much for your patience and for being such a dedicated part of this community. Now guys, in this lesson, we'll cover finding lengths, angles, and area of non-right angled triangles using the sine rule, the cosine rule, and the area rule. This will be uploaded in 5 sections. Section 1, we're going to focus on calculating lengths using the sine rule. In section 2, we will be calculating angles using the sine rule. Section 3, we'll be calculating lengths using the cosine rule. Section 4, we'll be calculating angles using the cosine rule. And finally, in section 5, we'll be calculating areas using sine. So, let's begin with section 1, calculating lengths using the sine rule. If a question concerns finding lengths or angles of any non-right angled triangle, we will need to use either the sine rule or the cosine rule. But we're just going to pay attention to the sine rule and then looking specifically at finding unknown lengths. Now, if it concerns calculating area of a non-right angled triangle, we will have to use the area rule that involves sine. So, first of all, we're going to talk about what is the sine rule and how can we use it. So we can only use the sine rule if we have a matching pair. We're going to look at what we mean when we talk about a matching pair. So this means you have to know an angle and the side that's opposite to that angle. Then if you know another angle, then you can find a missing side. Or if you know a missing side, you can find the corresponding angle. But key point, we must have a matching pair. So looking at this triangle here, labeled ABC, the side opposite to A, we would label that as little a. That is the matching pair. So I will qualify that. So if we know angle A and the corresponding side, which we would have labeled little a, then that's qualified as a matching pair. We could also know B, angle B, and its corresponding side, and that's also a matching pair. Or we could know angle C and its corresponding side, which is little c. So this is what we mean by we must first of all know a matching pair. Once we know that and we know an angle, or it could be a side, we can find any other missing value. So, what does the sine rule say? So, in any triangle, ABC, and these letters could be exchanged for other letters as well. Doesn't have to be A, B, and C. But in any triangle, ABC, the sine rule states that for finding unknown lengths, the rule is A over sine A is equal to B over sine B, which is also equal to C over sine C. Now, at no given point, we will need to use all three. So, if we're finding an unknown length, first of all, we're going to need a matching pair and then another angle. And then we can find the matching side to that. And we'll see what that looks like when we get into the question. So, what we need to do at this stage is to write down what the rules say concerning finding an unknown length using the sine rule. So what we're going to do now, we're going to go through 3 examples of finding an unknown side using the sine rule. So first question asks us to work out the length of side x. So we observe our triangle, we ask ourselves, is this a right angle triangle? And the answer is no. So at this point, we will then check, is there a matching pair? And if I look here, I've got angle 75 degrees and the matching side to that is 11. So I'm just going to label them A and little a, just to give us the focus that these two are the matching pair. Now I want to find side x. So also I will have to know the angle that's matching to x. So I'm just going to call that b and call the side for little b for x. So what we do first of all is to write the rule out, and then we're going to substitute directly into that rule. So since we're using a and b here, we're going to write that a over sine a is equal to b over sine b. So this is what I meant when I said at no point we would need to use all three letters at the same time. So we're going to now substitute our values in the formula and then rearrange it to make x the subject, hence finding the actual answer. So a is 11, so 11 over sine 75. The angle matching is 75, so over sine 75 is equal to b, which in this case is the side we're finding, which is x, over the matching angle to that is 24, so over sine 24. So now that we set up our formula, what we need to do is to rearrange this to make x the subject of the formula. So if you're not strong at rearranging formula, I would suggest that you watch the video that I've got on the channel about rearranging formula, and that will solidify your skills to access questions like these. So therefore, we're going to now cross multiply. So x times sine 75, we're going to write that as sine 75x. So sine 75x is equal to 11 times by sine 24. Beautiful. So next step, because we want to make x the subject, we need to divide both sides by the coefficient of x. So we're going to divide both sides by sine 75. So sine 75. Now this will cancel out and leave us with x as the subject. All we need to do at this point is to just put this value just as it is in our calculator. So we're going to do 11 times by sine 24. Good practice is to put 24 in bracket and then divide by sine 75. Now we're going to give our answer to 2 decimal places. So the answer is 4.63 centimeters to 2 decimal places. So whenever a question doesn't ask us to give a specific degree of accuracy, we're free to do whatever rounding we want, but it's a good thing to actually say what degree of accuracy you've rounded to. Now, just as this comes to my mind, one of the things that we do as mistakes when students are working this out, they forget to put their sign before the angle. So remember, it is sine and the angle. So do not forget to put the sign, else you're going to get an incorrect answer. So if you wanted to as well, you could just draw the matching sides so that you know which two works together. Beautiful. So we're going to do another example, and then we're going to look at the final example, but this time we're not going to be using our calculator. We're going to give our answer in the form of a simplified surd. So example number 2. So here we're asked to work out the length of side x. 3 marks. We check, we need to have a matching pair. So I can look here on the diagram, I can see that 6, so I'm going to label. So 6 and 51 are the matching pairs. So let's call that A and little a. And 81 degrees and x are also the matching pair. So let's call that b and little b. So we write our formula out again. Our sine rule for length states that a over sine a is equal to b over sine b. So once we've done that, now what we need to do is to substitute our values in. So little a is 6, so 6 divided by sine 51, and that's equal to b, and little b is actually x, which we're trying to find, divided by sine of 81 degrees. Beautiful. So now that we substitute, we now need to rearrange to make x the subject. So we're going to cross multiply. So here, x times sine 51, so sine 51x is equal to 6 times by sine 81 degrees. And again, we're making x the subject, so we're going to divide both sides by the coefficient, which is actually sine 51. So dividing both sides by sine 51, from here, you notice that all we need to do is to put our value, because these two will cancel out, leaving us with just x. So we're just going to put in our calculator what we've got here. You can use your fraction button, put 6 times by sine 81 on the numerator, and divide by sine 51 in the denominator. And again, we're going to give our answer this time to 2 decimal places. So we put that in our calculator. We get that x is equal to 7.63, and that's also to 2 decimal places. So we'll understand that once we have located our matching pair and we see the side we want to find, we set up our formula. It's just basically substituting into the formula and then rearranging to make the letter the subject of the formula. Absolutely brilliant. So now we're going to do our final example on finding the lengths using the sine rule. So in this question, we're asked to work out the length of x, but this time give your answer in the form, so let's underline that, k root 6, where k is an integer. Beautiful. So that means we cannot use our calculator. We're going to draw on our knowledge of simplifying surds. So same principle apply. We're going to ensure that we've got a matching pair. So I've got 60. So let's call this A, and let's call this little a, and b and little b. So again, we're going to just write our formula down. We're told that a over sine A is equal to b over sine b. So we're going to substitute into our formula. So little a is 9, so 9 over sine 60. So matching angle here is 60. And that's equal to, little b is actually x that we want to find, divided by sine 45. So sine 45. Beautiful. So that means we have to recall on our knowledge of our exact trig values. So I'm just going to draw the triangles to remind you. But before I do that, I'm just going to start cross multiplying and make our variable separated from the other side. So we're going to do x times by sine 60. So x sine 60 is equal to 9 times by sine 45. So clearly we're going to need the exact trig values of these. I'm just going to remind you of the triangles we used to do that. So for my 45 degrees, I need to get an isosceles triangle. So my isosceles triangle will have 1, 1, and the other side will be root 2. Now this is 90 degrees, so this is my 45, and this is also my 45. Now from this triangle, I can find what is sine 45. So how do I get my 60s? So from the 60s, we need to get a triangle. So this triangle, where we've got one hypotenuse is 2, and this side is our root 3. So 90 degrees again. So here is my 60 degrees, And because this was split in half, this is 30 degrees. So once I've got these triangles, and a good practice is to know these triangles as well, but once you know the triangles, you can find all your 45s, whether cos, sine, or tan, and also the 60s as well. So with that knowledge, we can now write down what is sine 60 and also what is sine 45. So remember, sine is our opposite divided by the hypotenuse. So what we need to do, go to 60 degrees, opposite from that is root 3, and the hypotenuse is 2, so it's root 3 over 2. So we're going to replace our sine 60 for root 3 over 2. So x times by root 3 over 2. Now you see where it's going. We're getting our surds in. Now we need to have sine 45. This means that we have to use the triangle that has 45s. So sine 45, and it really doesn't matter which one of the 45s you use, you will still get the same value. So again, sine is opposite, which is 1 over the hypotenuse is root 2. So sine 45 is 1 over root 2. So we're going to replace that. So 9 times by sine 45 is now 1 over root 2. Beautiful. So the same principle apply. We're just going to make x the subject. So we are multiplying here by root 3 over 2. We're going to now divide by root 3 over 2. So x then will be equal to, I can simplify this, 9 times 1 is 9 over root 2. And then we're just going to divide that by root 3 over 2. Absolutely brilliant. Now, key point here, remember, when we are dividing decimals, sorry, not decimals, fractions, we need to, 3 letters we always talk about, K, C, F. So we're going to keep the first fraction as 9 root 2, 9 over root 2. We change our division to multiplication, and then we're going to invert the second fraction. So now it will be 2 over root 3. Brilliant. Now, if you notice here, we also need to rationalize our denominator. So I'm just going to rationalize 9 root 2. So 9 over root 2, we've got to multiply by root 2. So 9 root 2 we will get from our numerator. And remember, root 2 times root 2 is just 2. So all of this here will give us 9 root 2 over 2, which is being multiplied by, again, we're going to rationalize 2 over root 3 here. So 2 over root 3. So rationalizing and multiplying both numerator and denominator by root 3. So 2 times root 3 gives me 2 root 3. And root 3 times root 3 is just 3. So we're going to replace that here. So 2 root 3 over 3. You can see why this is all of 4 marks. So now we just need to simplify. So I can simplify by dividing these two out. And also 3 goes into itself once, and into 9 goes 3 times. So all we need to do now is to multiply our numerators, because we can see we'll just get 1 in the denominator. So let's go. So we got 3 here left, and then root 2 times by root 3 is root 6. Now we can see that our answer is in the form k root 6. So our 3 here would be the value of k. So you can let your examiner know that I know what k is now. So we will say, therefore, k is equal to 3, because that's the number before the root or the coefficient of our root. So yes, we know how to set up our formula. We know how to substitute into our formula. We also know how to rearrange our formula, and we also know how to simplify our surds. So this question just brought all those pieces together, and this is the difference now with the student who will get a grade 5 or 6 versus the students who is able to get an 8 or a 9. Our ability to make connections across the curriculum by putting all our topics together. Absolutely brilliant. And remember, you can go back and you can play this again and watch all the steps that I have done. So now we've come to our key takeaways. Beautiful. So first of all, we talked about the fact that we can only use the sine rule if we have a matching pair. That means we have to know the angle and its matching side. If we know that, all we need to do then is to know one other angle if we're finding an unknown length. If we know another angle, we can find its matching side as well. Now, and I've also showed you what the matching pair look like, so you can go back to the start and have a look at that again. Another concept we talked about was the fact that if we're finding an unknown length, we use the rule A over sine A is equal to B over sine B, which is equal to C over sine C. And as we said, we do not always use all three of them. We will always be using two at a given time. And once we know that, we will be able to apply other concepts across the curriculum as well. Now, thank you so much for getting to the end of this video. And remember, we're going to be focusing on finding an unknown angle. So make sure that you hit the notification bell so you can see when part 2 of this video is uploaded. Make sure that you watch it over and over, share it with a friend until you get that concept. Thank you so much for watching.